Okay, so having reviewed all of the components on the schematic, the only thing that's left right now is reviewing the labels. And it's very easy because I use the labels to connect different wires together. Like for example, I have like anything here, for example, LCD D3. It connects to the same label at the CPU side, but it's also very easy to miss some labels. And for example, just have a label connected to one chip, but not connected anywhere else. So I think that reviewing the labels is a valuable step in ensuring the schematic is correctly connected. So what I'm going to be doing now is reviewing the labels. And in order to extract labels from the schematic file, I've written this little Python script that uses KiCad library utils. I made a few changes to KiCad library utils. You can find them on GitHub on my remote here. With those changes, I can extract the labels and output them as or just print them out on the terminal. And basically what I do then is just let's see, redirect this output to a CSV file, which becomes the file that contains all of the labels. So I will just let's see, I'll just open up this file, and here we have all of the labels. It's very easy to see right away that some labels are connected wrong. For example, here is a label that I only have one such label on the whole of schematic, so it's not connected anywhere else. And this is an error. This is going to be a pin that's just unconnected. And there are other labels like that as well. For example, switch enable label is not connected anywhere else. Like if we don't connect that label anywhere else, it's not going to be possible to read any of the switches. So things like this are just some of the examples of the things that one can find if reviewing each label one by one. But of course, if there is more than 2 copies of a label, it's sometimes not possible to see just from this file whether this label is correctly connected or not. So I have to go through every single label, and I have to go through every single I have to first think where is this label supposed to be connected, and then I have to see where it's actually connected. So let's see. Let's start with the first label here, and I'm going to do as many labels as I can in this video. We'll see how many labels I can do before my dog needs to go out, because she's getting very restless right now. So she really wants to go out and play. But I'm going to see how many labels I can do. So I'm going to start with this first label. And I'm going to go to my schematic and search for this first label. And I'm going to select match whole word so that I only find that label. I can see right away that the first occurrence of this label is connected to this power chip. And this controls the 5-volt supply on the joystick inputs. So any joystick that's going to be connected to this board is going to be driven by this power management IC. And this needs to be connected to the STM32 as well. And we can see that it's connected to a GPIO pin. And also it's connected somewhere else. And we can see here it's connected to this 0 ohm resistor, which is marked as no fit. So it's commented out. This resistor allows feeding the VDD303 MCU to this enable input of this chip in order to maybe sort of keep it always enabled. Actually, this is probably not strictly necessary. I just added it at the same time when I added this 0R resistor. This one allows bypassing this chip completely. But we can say that this label is totally fine. So I'm going to mark this as green, and I'm going to move on to the next label. So next one is analog in. Let's see what this could be. Can I not select this? What the hell? What is this? Why can I not? Oh, there we go. So So going to KiCad, A in OC. Right, so this is the overcurrent flag, which goes, I think it goes low, but I have to look this up. In this case, it doesn't really matter, because this is connected to the processor, at least it should be. This is connected to the GPIO expander, right? And this GPIO expander has pull-up resistors, so it's if this flag is an open collector output or open drain, then there is pull-up resistors in here to accommodate for pulling that line high under normal circumstances. Where else is it connected? Right, so and this one is connected to a tape resistor, which is the pull-up resistor. Do we need that 10K resistor? I'm going to keep that pull-up resistor for now. It could be useful. The pull-ups in the SPI GPIO expander, they are rather large. I think they're like 100K or something. Usually pull-ups are at least 50K on GPIO pins. But in this case, I think this is totally fine. I can just green light this connection and move on to the next. So next is the VDD 5 volts. We got 13 occurrences of this label. For some reason, I cannot double click. This is really annoying. I cannot double click and select all. So I have to go there, and when I do select all, it selects like everything. This is really annoying. I don't know why that happens. So let's see. Okay. That didn't work. I'm gonna close this one. I'm gonna save this as ODF. Let's see. Yeah. And maybe if I open it again, maybe it works then. Let's see. Yeah, much better, much better. Okay. Let's see. So this one goes to each one of these outputs. So we got the output of the chip. It's going to be 900 milliamps, by the way, going out here. It's the same circuit as is usually used on USB ports, where you need 5 volts, but you have to protect that 5 volts against short circuit. So this chip will automatically turn off this power if there is a short circuit somewhere here on one of these connectors. So let's see, we have A in VDD 5 volt. And yes, and then there is the capacitor, which is wrong, by the way, because this one is intended for the op-amps. But the op-amps, I've changed the op-amps from being connected to the A in VDD 5 volt to being connected to actual 5 volt. So this is the first mistake that I find while reviewing these labels, which is very nice that I find this. So let's make this VDD 5 volt. And this one as well. So that these two are going to be bypass capacitors for the op-amps. Obviously, they're connected to that power supply. They're no longer bypass capacitors for the op-amps. So this was it, I think. Now we should have, let's see, how many of these? Should it be 9? Let's see, 9, 10, 11, 13. Interesting. Oh, okay. Yeah. there is another one. So this one is, these are the capacitors, the bypass capacitors for these connectors. So they're going to go right by each connector. All right. So I can green light that label, and I can move on to the next label. Let's see. Make this label green. And AP reset. And again, I have this really stupid issue where I cannot click on anything. Copy. Maybe this works. I cannot double click in the cells. That's very annoying. So AP reset is for this digital potentiometer, which controls the joystick emulation outputs. It should be connected to the main MCU. Yes, or through this GPIO expander as well. That works too. So there's only 2 connections there. That's fine. I can make this green. I'm gonna copy that one. APSCL, that's gonna go to the I2C port, the main MCU, and it's shared with let's see. So that didn't copy properly. Let's see. Okay. Yeah. Obviously, because I have this box ticked in, I have to enter exact names. So I have SCL, and that connects to the MCU here, to the shared I2C1 port. Let's see, and this is SCL also. Cool. So that's fine. Next is SDA. And this is connected in the same way. That's done. And the right protect pin. Now it worked. So right protect pin is connected to probably also to the same GPIO expander. Yes, that's correct. Let's see. And that one doesn't work. So LED enable. This is gonna enable or disable the LED outputs. So when this goes high, the LED outputs will be enabled. So this has to go to the processor. Yes. So it could go technically to the GPIO expander as well, but I had enough pins on the processor, so I connected it directly. That's correct. Let's see what we got next here. So that would be B-LED interrupt. B-LED interrupt. That's also connected to the processor. This is going to be a GPIO pin. That's correct. And B-LED SCL is going to be connected to the same I2C port as let's see, as this digital potentiometer. See if this is connected there. Let's see, SCL. Yeah. And I have 3K pull-up resistors here for this I2C port. They're implemented here. And I also noted down the I2C addresses. They don't seem to conflict, so I think this should work just fine. So we got the B-LED on 32, AP on 58, and then this other digital potentiometer on 55, and EEPROM on A0. So it should be fine. Let's see. SCL SDA boot 0. Got 3 connections on boot 0, and that's probably the connector for the debug and also the pull down resistor. So boot 0 has a pull down resistor, and then it connects to this this debug port where I have JTAG, a console, reset, and also usually I have SVO, but I couldn't connect SVO because I had to use that pin for something else. I think it was for the MOSFET drive. Let's see. So this was fine. Break. Now break is a label that's actually an artifact. This label doesn't even make sense. Let's see. It's connected down here. It's connected down here. And the only thing that it does is just lead the main power to this break resistor circuit. And then VMOT actually comes from here. So the power is split here between the logic and the motor supply. And the motor supply is fed through this power diode here. And there's also another diode here, so that this power is a little bit more evened out by this capacitor. But the break doesn't even actually make any sense here. This would be better called like, let's see, mod, let's see, VMOT in. We can call it VMOT in actually. And then I can greenlight this label as well. And next is kind of DCS. Kind of DCS. Where is kind of DCS connected? So it's connected to the kind of the protocol driver, which is this chip, and it's connected to PG10, which is going to be a GPIO, and it also has a test point. So that's it for kind of the CS, which makes sense. Kind of the interrupt is the same thing. It needs to be connected to the MCU, and it has also a test point. So this is going to be kind of the int. Let's see. And it's going to be using the internal pull-up resistor of the STM32. Right. Next. Next is Miso. Alice, come. So Alice wants to play now. She's been sleeping for quite some time while I've been working. So now she's awake and wants to play. So it's highly unlikely that I can do any more work right now because she's not going to give up. She's going to pick up something. She's going to find some ball, or she's going to find something else. She's going to come and she's going to drop it. She usually comes and drops it like by my feet. So she's not going to give up, and then she's going to start jumping up because she wants to play. And for the most part, no works fine on her. Like I can say go lay down. Alice, ligg, ligg, ligg. Så bra, ligg, ligg, vänta, bra. And that works for a while. So she's laying down and looking at me, and now she's up again. The moment I looked away, the moment I looked at this document here, she just jumped up, and now she's sitting down. So this is not going to work very well. So I have to stop this video, and I have to continue with this a bit later. But the general idea is that I'm going to go over all of the labels and see, make sure that they're connected correctly. Nej, ligg, 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 Lee. Lee. Yeah. Now she's trying to make a go for a toy, which I've hidden so that she wouldn't get it. But she kind of knows what it is, so she's trying to make a go for it. Anyway, so I'm going to continue with this later. I'm going to stop the video, and before I do that, I'm going to check. Let's see. I'm going to check the YouTube here. Okay. The YouTube live icon is red, so it's kind of complaining that it doesn't get enough keyframes. But usually it does that because the screen is not moving, so the keyframes are not sent very often. So it seems to work fine anyway. So hopefully this doesn't lag too much. All right, thanks for watching.